Hey everybody, so this video is a design log for the Dream Team design challenge facilitated by Hackaday and Supplyframe. I'm part of the Need Lab team and we're designing for CalEarth. One of our potential routes is a Lidar dome measuring device, measuring the internal surface of a dome structure and giving visual feedback using a laser. So the base of the device here is made so that it fits onto a camera tripod. So it's a 1/4 inch thread. This is a 3/8 thread. It's designed to put a metal insert inside. So this part is 3D printed. Most of the large parts in this video are 3D printed. So this thread here is cut so that you can put a metal insert inside for durability. So you notice this hexagon here. The idea behind this base is that the rest of the device can be lifted out and taken off-site when you leave, but you can leave this part in place so that you can return to site and easily put it back in, whilst not leaving any of the expensive electronics components on-site overnight, and not having to recalibrate the whole system when you return the next day. So yeah, you have this hexagon place here, which basically is the 0 point. And then you have a second piece which fits on top. So if you look, they interlock into each other, like so. So then you see on this part, there are 6 pegs. These 6 pegs are designed to hold bearings. So you have one here, and then 6 more here, 5 more here, 6 in total. So you have 6 bearings here. They'll just be pressed on using friction, as not much force is applying to them. If needed, we'll use super glue to hold them in place, but that's something we need to test in physical prototyping. And the next part is the body. So this part is the part that needs to be able to rotate 360 degrees. It does so by sitting on top of the bearings. Notice there's a skirt down the side. This is to protect the bearings from dust. Like if dust and gravel, pieces of debris get above the bearings, then it will cause the whole thing to bump up and down as you rotate it, or become uneven as you rotate it, and then you won't have an even measurement, which is not good. There's one other thing that we've added, which is a steel disc inside. So if you look inside here, there's a steel disc which the bearings rest against. So this means that you get a steel on steel contact for the motion, to support the motion. If it was the bearing touching against the 3D print, the surface of the 3D print is likely to be bumpy, so the motion won't be smooth and it will wear over time. So we're putting in just a simple steel disc so that you get this smooth steel on steel action. So within the top section, you have most of the electronics components housed. The first is a Raspberry Pi, which you can see here. There's a small notch cut on the side so you can access the ports, and the rest can be accessed from this side. Next is a laser module. So the purpose of this laser module is to create the visual feedback from the Lidar sensor. So one detail we haven't finalized yet is like a mirror system which attaches to the Lidar sensor and directs this beam to the exact same point that the Lidar is measuring and ensures that they're synchronized all the time. This requires really fine calibration. It will most likely be a series of mirrors attached to the Lidar sensor itself, but this laser has to be shot exactly in the middle of the first mirror so that it bounces correctly and then is projected and exactly straight from the device. So to do this, we've added 4 nuts here and then 4 bolts. 1 here and 3 more here. So these allow you to apply a little bit of tension on the rear of the laser, and it allows you to position it exactly where it needs to be. So one thing I should mention is the inside of here. So this hole pokes all the way through, which is the exact diameter of the laser, but only for the first 2 millimeters. The rest is chamfered, so it drops back slightly, so you get a slight border around the edge, and this allows it to move in a very, very small amount in each direction so you can position it correctly. So it's only the first 2 millimeters that is 1-to-1 fit. The remaining 8 is slightly wider, and this gives you that little bit of wiggle space. So the next thing to mention is the spirit bubble. So the spirit bubble ensures that when you first calibrate the device and set it up, that it's on a perfectly flat plane. This is important because if the device is at an angle, then the dome that you build will be at an angle. So we found these like 30mm surface mounting spirit levels that can simply be stuck on or screwed on depending on the one we decide on finally. Next is the Lidar sensor itself. It just screws onto the side or bolts onto the side. And there's a small notch cut in the back of the enclosure, and this allows for the ribbon cable to be plugged in and then run down underneath. And finally, there is a dust cover. So this dust cover will either be 3D printed or made from sheet material and then folded over. We're not quite sure yet. There's a notch cut inside, and this allows the laser and the LiDAR sensor to be able to project out. We're not exactly sure of the size of this right now. It might need to be a little bit wider to stop reflections, but the smaller it is, the more protection it provides. So we'll start with this and see how it goes. So yeah, this is the device so far. A few details need to be tweaked and modified, but it's 90% there. Thanks for watching.